Hi, I'm Sydney, and I'm coming to you from the Flight Research Building, also known as the hangar, at the NASA Glenn Research Center. NASA has a challenge to share with you, and we want to see your solutions. It's called Let It Glide. In 1958, the NACA became NASA as we know it today. Even after 100 years of research, NASA continues to study and improve flight. Today, I'm here with Glenn Research Center's Chief of Aircraft Operations, Jim Demers. Jim, can you tell us a bit about the research done on NASA's aircraft?
Of course, Sydney. We load scientific equipment into these planes and study the world around us, from as low as a few hundred feet above the ground and up to 40,000 feet in the air. We are currently using our Twin Otter aircraft to study the harmful algae blooms in Lake Erie, and our T-34 is being used to test communications for aircraft. We are also researching unmanned aircraft systems like drones and how they will work alongside piloted aircraft.
So what determines which plane you use for which research?
That's a great question. We modify our aircraft for different types of research. For example, the Twin Otter was designed to fly at lower altitudes and land on short runways, while the S-3 was made to fly high, fast, and land on aircraft carriers. Our S-3 Viking performs well at lower altitudes close to the ground, as well as the mid-altitude range. You'll notice the wing shapes and thickness, fuselage designs, and engines are different depending on the aircraft's intended mission or use. Based on these features, the planes will perform differently, giving us the ability to fly greater distances at higher altitudes, at faster speeds, or carry more weight. We then choose the plane that will do the best job for the scientific research we are working on. NASA is currently developing an experimental aircraft designed as a low-boom vehicle to reduce or almost eliminate the thunder-like sound produced when an aircraft flies faster than the speed of sound. This noise is called a sonic boom. This research could allow supersonic flights over the United States and make air travel faster and more efficient.
So here's where you come in. To better understand the aircraft features that Jim mentioned, we want your team to design and build a glider out of a shoebox that could model one of these types of aircraft. To complete the challenge, you and your team will explore the 4 forces of flight and work through the engineering design process to come up with the best design possible. You will need to design and build a glider that must include an intact shoebox that simulates a space for a scientific payload to carry instruments for in-flight research. Show improvement in glide slope with positive % change over the course of the challenge, and not break apart in flight or upon landing. There will be opportunities to interact with NASA scientists and engineers like us.
When you've created your final solution, your team will present it to NASA.
As future scientists and engineers, NASA needs your help in solving this real-world problem.
Good luck, and we look forward to seeing your solutions.